Do you know we're going back to the moon? On November 16th, 2022 at 1:47 a.m., NASA's SLS rocket ignited its 4 RS-25 engines and pushed Commander Munikin Campos along with 5.5 million pounds to a speed over 17,000 miles per hour up and out of our atmosphere in the biggest rocket ever launched successfully, officially kicking off the Artemis program. After the initial launch and acceleration towards orbit, boosters separated. They jettisoned the launch abort system. The core stage main engine separated, and Orion was on its way to deep space. It dropped off some CubeSats with some science experiments out there. It did a couple of laps around the moon, did a return-powered flyby burn, and headed back to Earth, where in just a day from now, the crew cabin, populated by a couple of mannequins in jumpsuits, will burn in and parachute down to safety. I'm doing a series of videos about what we're going to go up there and do in space, starting with an overview of the next generation of NASA missions, the Artemis program. The scientific breakthroughs of Artemis could very well define the changes in life of our generation. There's a reason basically all of the really cold countries on Earth are, for the most part, super advanced places technologically, and so many of the hot countries around the equator are still basically just farming and scraping by. Cold places are really hard to live in while cold. When the environment you go to live in is categorically deadly, you're forced to innovate to survive. And a fun side effect of that innovation is unintended scientific advancements abound. That, and if there's something on that space rock that's valuable, you better believe we're gonna get up there, build a perimeter, and take control of it. Also, Mars is calling. If we intend to go survive in a place so remote, so inhospitable as Mars, NASA wants a dry run that's just a hop, skip, and a jump away for dress rehearsal. So we go back to the moon and we do the other thing. But we're not just going back there. The plan is to build a base on the moon and an orbiting space station called Gateway, which will serve as the welcome center between the Earth and the moon, and in the pretty near future, between the moon and Mars. The LRO, Lunar Reconnaissance Orbiter, this little guy, has been making a very detailed map of the moon's surface since launching in 2009. We now have a 3D topological map of the whole width. The lunar South Pole was the chosen landing site to get started on Artemis Base Camp. Why the South Pole? Well, to oversimplify, there are a bunch of craters that are deep enough and situated at such an angle from the sun that they have never received sunlight. One of the outcomes of this is that there is water ice in those craters, and a lot of it. Turns out that when you have water, you can make hydrogen. When you have water and hydrogen, you can do two very important things: keep humans alive and make rocket fuel. NASA plans to come and go from the Artemis Base Camp fairly often, and the less fuel you have to carry from Earth, the better. It costs something like $18,000 per kilogram of stuff you launch into space from Earth, which means if we've got a rocket fuel factory just humming away on the surface of the moon, once we finally get going on those Mars missions or wherever else we go, we will only ever need to launch from Earth with enough fuel to get to the Gateway, which is orbiting the moon. More on that in a second. Then they can refill the rockets with moon fuel, and since there's so much less gravity around the moon than there is around Earth, not to mention the moon is spinning around the Earth in the direction we would need to go to shoot towards Mars, the Gateway can act as a slingshot, and deeper space travel gets way more affordable. So, the Gateway. During the Artemis 3, 4, and 5 missions, NASA will be assembling a complex ship in deep space. It'll have a living and working quarters, a Canadian robot arm, and then a series of detachable modules necessary for the comings and goings of commuting between Earth and the moon. Here's how that plays out. The HLS, the Human Landing System, a SpaceX Starship design variant that will bring people from the Gateway down to the surface of the moon. That docks to the Gateway. Next, astronauts arrive on the Orion and deliver a bunch of equipment and food and water and anything else you might need to camp out there. Then the crew hops on the HLS and bebops on down to the surface of the moon. There, they perform science. After science, they return up to the Gateway on the HLS. The astronauts hop back into the Orion and are brought back to Earth. Meanwhile, a new logistics module docks to the Gateway with food and water and equipment and everything that's needed for the next round. The next HLS arrives, refueled and ready to go back down to the surface of the moon. Right on time, Orion returns with some astronauts and a new airlock system. Those astronauts hop onto the HLS and pop on down to the moon. And this plays out on and on repeat while we bring things up and we bring things down and we look at things under microscopes and we dig up artifacts from the civilization of lizard people that used to live on the moon, and on and on and on. The Gateway has a rather odd looking orbit, a polar orbit, meaning that it's going north to south and it's really elongated on one side. That's primarily designed so that there's never a blackout period in communication between the Earth and the Gateway and the moon. But it can also serve as a slingshot to send satellites or whatever else out into deep space. You see, the moon orbits the Earth at a relative speed of 2,200 miles per hour. And I don't know how close he got on the numbers, but according to this QORA answer, in order to orbit the moon, the Gateway is going to have to travel an additional 3,700 miles per hour, which means that anything you send rocketing away from the Gateway will start at 6,000 miles per hour combined relative to Earth. And that's before using any fuel. That math is super approximate, and it would depend on the direction everything is facing at the moment that you leave, but you get the gist. The HLS, the Human Landing System. NASA has decided on 3 different companies as partners for building the landing vehicles. We don't know yet which one of these will be the first company to land a woman on the moon, but all 3 of these companies will be working with Artemis over this next spacefaring generation of missions. First, SpaceX. They have a single-stage system, the Starship. They're already planning a demonstration where they're going to do an unmanned fuel transfer. Look at these little spacemen who are going to ride their little space elevator down to the surface of the moon. Next up, Dynetics, whose lander is super low to the ground, so the crew will just be able to pop out and pop back in pretty easily. And finally, the National Team, with none other than Amazon's Jeff Bezos' Blue Origin as the prime vehicle. The Base Camp. After a successful completion of the Gateway, NASA has proposed construction of a moon base. They want to have a permanent presence on the moon, with astronauts living and working there full-time with up to 2-month-long deployments. The mission parameters would be to study the surface of the moon, conduct experiments, and test habitats that would eventually be used on Mars. The moon base will initially have 3 components: the foundational surface habitat, the Habitable mobility platform, that's tough to say, and the Lunar terrain vehicle. The foundational service habitat will be a pressurized living and working quarters, basically a home base. Astronauts would be in there without their spacesuits on, just doing their science and bouncing around. The Habitable mobility platform would also be pressurized and would be designed for crew transport over long distances. Evidently, the plan would be so that you can live in this thing up to 14 days while it lumbers across the surface of the moon. Toyota is in the running to head up the design. And the Lunar Terrain Vehicle is basically a beefed up version of the moon rover from the 60s and 70s. This thing is made for bombing around the surface and doing science. This one, as well as the Habitable mobility platform, would be able to be controlled remotely. Riding along in this first mission is a number of CubeSats, little satellites, some of which will be released along the way to perform a bunch of science. I'll go in depth onto what each of them are doing in a future video, but one of the experiments is to see just how terrible deep space ionizing radiation is for living things. On and around Earth, we have this delightful force field called the Van Allen radiation belt. It deflects these ionized radiation space beams of space. Turns out everything about space tries to kill people at all times from all angles, always. So that's neat. With Artemis 1, they're launching up some fungi, some plant seeds, some algae, a little bit of yeast, and then they're going to bring it all back and see how the different DNA held up, and what we'll need to shield against to have people live out there for a long time without turning into the Greys or whatever we're afraid of. So actually tomorrow, December the 11th, 2022, the unmanned Artemis 1 mission should be returning to Earth. It went up with no crew, buzzed around the moon, tested a ton of things, did some science, and now it's almost back home. Artemis 2 will be launching sometime in 2024, and this will be a crewed mission that does a flyby of the moon, testing Orion and its habitat, and I believe bringing humans further away from Earth than they've ever been before. And then Artemis 3 in 2025 will drop off parts of the Gateway in orbit before returning humans to the surface of the moon for the first time in a generation, where they will look for water, scrape at the surface a bit, take a peek around the prospective base camp site, and test a bunch of stuff down there before blasting back off, returning to the Gateway, leaving it out there, and coming back home to get us all pumped up and hopefully secure funding for Artemis's 4, 5, and 6 and beyond. That's all I got.